So we're going to do another related rates problem here. This one involves a changing voltage. And one thing we know is that the voltage, V, measured in volts, the current, I, measured in amperes, and the resistance, R, measured in ohms, of an electrical circuit, as the one is shown here, are related by this equation, V equals IR, voltage equals current times resistance. Suppose that voltage is increasing at a rate of 1 volt per second, while I is decreasing at a rate of 1/3 ampere per second, letting T denote time in seconds. So part A says, what is dV dt? So that is the rate, when we think about dV dt is the rate at which the voltage is changing over time. And so V is increasing at a rate of 1 volt per second. So dV dt equals 1. And again, that is volt per second. So we're just identifying characteristics of this problem. So part B says to find dI dt, and I measures current, and so this is currents per second, or amperes per second. We measure current in amperes, so amperes per second. And we see that I is decreasing at a rate of 1/3 amperes per second. So this would be negative 1/3. And we'll say amps per second. So if we want to know which equation relates dr dt, dv dt, and di dt, we're going to take V equals IR, the given equation that we know, and we're going to differentiate with respect to, you guessed it, time. So I've got V equals IR. So differentiating with respect to time, we'll have for part C, I've got d dt of V equals d dt of IR. So the derivative of V with respect to t, derivative of V, any variable, that's just going to become a constant, 1, the coefficient there. So this becomes 1, and I don't really need to write the 1, but since I differentiated V with respect to t, I'm going to write dV dt. However, when I get to the other side and I look at differentiating I and R, we need to recognize that we have a product there. So I need to use my product rule, and I'm going to write this out. Because when we use our product rule, we say first times the derivative of the second plus second times the derivative of the first. So here I would have I times the derivative with respect to t of R plus R times the derivative with respect to t of I. So we simplify this and we get dV dt equals I. The derivative of R is going to be dr dt plus R, and the derivative of I is going to be di dt. So this is my derivative equation that relates the rate of change for voltage, current, and resistance, all simultaneously. So part D says, hey, let's find the rate of change, or the rate at which R is changing, the resistance is changing, when I know we've got V equals 12 volts and I, the current, equals 2 amps. So we're going to determine, is the resistance increasing or decreasing as well? And we have information. We have that dV dt is 1 and di dt is negative 1/3. I can plug those values in. So we're looking at the equation we have here and keeping in mind what we know. So we know dv dt is 1. We know di dt is negative 1/3. We have the relationship v equals IR, and we know we're dealing with this at a specific moment. We can find R because we know that V is 12 and I equals 2. All right, so we'll plug in 1 for dv dt. My I value is given at that moment. We're at 2. dr dt is what we're being asked to find. Now, I don't have an R value here, but I do have an equation that relates V, I, and R together. And if I know V and I can find R. So V, 12, equals 2 times R, or rather 6 equals R. So I'm going to plug my 6 in for R, and di dt is negative 1/3. So now I only have one variable, and that's what I'm being asked to find, the dr dt there. So we'll just solve this equation. And in this case, I have 1 equals 2 dr dt. 6 times negative 1/3 is minus 2. I'll add the 2. I get 3 equals 2 dr dt, or 3/2 equals dr dt. So we can leave that as a fraction, but it's also 1.5. So dr dt equals 1.5. And this is resistance with respect to time. So resistance is measured in ohms, and time in this situation is measured in seconds. So it's 1.5 ohms per second. That is the rate at which the resistance is changing with respect to time. 1.5 ohms per second. And because it's a positive number, we can say it is increasing. All right? So I have one more example for us coming up in the next video.